Hello, Accelerated Math 6 or 7, 8 students. We are working in Module 12, and this is going to be Lesson 12, and it is called the Fundamental Theorem of Similarity. And the Fundamental Theorem of Similarity is a theorem that talks about why things are similar and why things are congruent and the same and all of that kind of stuff. So our goal for today we will learn how to prove the fundamental theorem of similarity, short for FTS. The question that I want you to think about is, what is the fundamental theorem of similarity? All right, so we're going to do a little activity, and these are the materials that you need to have in order to do this activity. You will need a ruler with centimeters, a protractor, and a calculator. So a ruler with centimeters, it's here, a protractor, and a calculator. And then I also need a piece of lined paper. And you have lined paper in your notebook because that's where we do all of our work. All right, so for the last couple of days, we have been talking about dilation and what happens with dilation, how a figure changes because of dilation. And now what we want to do is we want to use what we know about dilation to come up with some conclusions about the concept of similarity. And some of you know what similarity is. If something is similar, that means that it looks the same. It may not have everything the same, but it looks very close to being the same. So looking at this piece of notebook paper right here, what do you notice about the lines on the piece of notebook paper? And if you notice on the notebook paper and the lines, you will see that they are all what? What are they all doing? And if you're thinking to yourself, well, they're all equidistant from each other, they're all going the same direction, they never intersect, all of those things that you just mentioned are the things that I want you to pay attention to, okay? So the lines on the notebook paper are parallel and they don't ever intersect. So keeping that information in mind when we go through this activity, on the first line of your paper, I want you to mark a point, okay? So on my paper, here's my paper, and I'm going to put a point. All right, and we're going to name that point O. So we're calling this our center O, okay? Then it says I want you to mark a point P a few lines down from the center O. All right, so I'm going to mark a P right here. And that's letter P, okay? And now what it's asking us to do is it's saying draw a line from the center O. It's actually a ray, sorry. Draw a ray from the center O, and we're gonna find another spot after we do that. So I'm gonna go ahead and draw a line connecting point O and point P. And actually, it's not a line; it's a ray. Let me use the correct vocabulary words. So. Go. All right, so there is my ray from the starting point of O through point P, okay? And now it says, now choose P prime further down the ray, also on one of the lines of the notebook paper. For example, you may place point P 3 lines down from the center and point P prime 5 lines down from the center. So I went down 1, 2, 3, 4, so I'll go 6. 1, 2, 3, 4, 5, 6. Let's go a little bit further. We're going to put it here. So this is going to be P prime, like it says. Okay? So now what I'm supposed to do is it says, use the definition of dilation to describe the lengths along this ray. So we're going to say that O P prime and O P are all on the same ray. We do know that about him. We know that OP is a shorter segment than OP prime, okay? And then what we have to do is we have to just see if OP prime is a result of something happening to OP. And the answer to that question is yes, it is, because P was the initial point. Then we did something to P in order to get P prime. And all along we've been talking about dilations, and a dilation is when you take the scale factor and you apply it to the first segment, and that's what creates the new segment. In this case, OP is multiplied by a scale factor, and then OP prime is found. And so what we can do is we can try to figure out what that scale factor is. And remember, the way that you find the scale factor is you take the result, or OP prime, right? And we divide it by the original, which is OP, and that will tell me what was the scale factor that allowed me to create it. Okay? And so these are a little bit of review that we haven't done for a long time, but you need to start bringing it all back together. So, for example, if we use the lines on the paper as our scale, then we could say that OP prime is 1, 2, 3, 4, 5, 6, 7, 8 lines, right? And we could say that OP is 1, 2, 3, 4 lines. Okay, so we take OP prime divided by OP, and so we got a scale factor of 2. So that's how we were able to find the scale factor. Okay, and so that helps us figure out how this scale factor right here is important. Okay, so now it says that we want to take it a next step. And it says draw another ray, OQ, use the same scale factor to mark points Q and Q prime. For us, we would place Q 4 lines down, because that's where P's at. So I'm going to go 1, 2, 3, 4, and put a point. And that's going to be called Q. And then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and put Q prime, because that's where the P sat. And it said, now draw another ray and use our same counting system, which is what we just did. So I'm going to switch out and put a pencil on there. And then connect our points. Okay. And now we have this. Okay. So now it says, now you're going to connect point P to point Q and point P prime to Q prime. What do you notice about those lines? Okay, so if we connect these two, like it says, connect, done, and now we have to connect these two, like it says. The question that I need you guys to think about is, what do you notice about these two lines right here? We could say what about these two lines? We could say that the lines are parallel. Okay, that's something that we could say. All right. Now it says use your protractor and measure angle OPQ and angle OP prime Q prime, and what do you notice and why is that so? Okay, so now we're going to use our protractor to measure the angle measures. And so our angle measure here is 40. Let me make sure they're lined up, sorry. My head's probably right in the way of your video. So I see it as being 40, 41, 42, 43, 44. So I'm going to say this one is 44 degrees. So now let's measure what this one is. Hopefully you will notice something. And if we were to extend our line out, remember how we used to do that? Well, we're still doing that. And what do you notice? 44 degrees again. So this is always also 44 degrees. Okay? So now we measure the angles, and what do you notice about those angles? They're equal in measure, and they must be equal in measure because they are corresponding angles. Okay, so this is fun. So the angle OPQ is equal to angle OP prime Q prime because where are they sitting? You have parallel lines cut by a something. What is this called? In this case, this is called a transversal. So bringing back all this information that we've been learning, so we know that they're equal because they are corresponding angles, because the lines are parallel, cut by a transversal. Okay? So all of those things that you have been learning so far, do you see how all of them can be applied to this activity? Okay? So now I would like you to decide, without using a protractor, what could you say about angle OQP and OQ prime P prime? What could you say about those? And come up with a reason. Okay? So now the last thing that I need you to do is it says use your centimeter ruler to measure the segments of OP and OP prime. And let's find out what the measurements are. So remember to use the centimeter side, not the inches side. So we're measuring OP. Okay. So I got on mine that it measures about 4 point, I would say 0.07 centimeters. Okay, and then let's see what this one measures. On this one, OP and then OP prime. Make sure that I get it lined up right exactly where it's supposed to be. And on this one, I got 8.2 centimeters. Okay, so because we're off a tiny, tiny bit in the in-between, what did we say the scale factor was? Remember, it says equal to the scale factor. So we would have to go segment OP is the original, OP prime is the dilated amount, and so you have 8.2 divided by 4.07, and when you do that, we're using the calculator, let's figure it out, 8.2 divided by 4.07, and you get about 2. It's very, very close, as you can see on the calculator. It's like 2.0147. So that is very, very, very close to being 2. So that's 2 different places that we were able to show using the information that we have to come up with the scale factor. The original ones was the distances on the lines, and then the more accurate one was actually using the ruler to figure out what the scale factor is. And as long as your scale factor is matching, then you know that you're on the right track. Okay? And so what you have just created by doing this is what the fundamental theorem of similarity is. Okay? So it says to keep in mind that the dilated points P and Q from the center O along their respective arrays, do you expect the segments PQ and P prime, Q prime to have a relationship where the PQ is multiplied by the scale factor to get the P prime, Q prime? And the answer would be yes. Okay. They do all have the same scale factor when they're dilated. Okay, we have one more thing that we need to add to this. It says now mark point A on line PQ between points P and Q. Okay, so mark A on, let me read again. Mark point A on the line PQ between P and Q. So we're going to put A, let's put it right here. Okay, so there's A. All right, and now it says draw a ray from the center O through point A and then mark A prime in between. Okay, so we can do that. So we're drawing a line from here through point A. Okay, so there's point A. All right, and then it says, and then mark point A prime on the line. And the question that you have to ask yourself is OA multiplied by the scale factor to equal OA prime. That's the question that I want you to figure out. Is OA times the scale factor going to give us OA prime? So let's try it. Using our centimeter ruler, we're going to measure 2.9. Okay, so if we take 2.9 and we multiply it by 2, we should get 5.8. So we're trying to see if this segment from O to A prime is 5.8. Let's see if it is. So we line up our intersections. And if you look, check it out. Get my big noggin out of the way. Here's 5. Okay. 0.5, 6, 7, 8. Right on the dot. So this distance from here is 5.8. So it worked. Okay? So again, choosing a different point and having it work, the answer to this is yes. Because we know that our scale factor was 2, and every time we take an original segment, angle, ray, whatever it is, if you apply the same scale factor, you're going to come up with the produced results. Okay? So it's pretty cool. All right. So we could keep doing that with several other things, and we could come up with many ways to prove it. So it says, does this always happen no matter the scale factor or placement of the points? And the answer is yes. The main reason is because you're using the same scale factor every time. All right. So what we need to know is we need to know what the fundamental theorem of similarity is. Okay? And the theorem says, given a dilation with a center O, so we have a dilation with a center O, okay, and a scale factor. Our scale factor happened to be 2, okay. Given a dilation with the center O and the scale factor, then for any 2 points, P, Q, in a plane, so that O, P, and Q are not collinear, that means they're not on the same line, they're on different lines, the lines PQ and P prime Q prime will be parallel, where P prime equals the dilation of P and Q prime equals the dilation of Q. Okay? So basically what we're saying is if you have a center O and you have 2 points all on different lines, if you multiply them by a scale factor, you will get parallel lines that result. Okay? So the fundamental theorem of similarity is a center point, 2 different points on different locations on the so when I say different locations, P was here, Q was here, but they're the same distance from your center O. If you multiply them by a scale factor, the resulting line will always be parallel. Okay? And that's what the fundamental theorem of similarity is. Okay, so I have it actually written down so that you can copy it into your notes because it's kind of cool. All right, the goal of this activity is to see the properties of the fundamental theorem of similarity in terms of dilation. FTS states that given a dilation from the center O, the segment P and Q create a segment P prime Q prime. The dilation makes the segments parallel. So segment P prime Q prime is a result of multiplying segment PQ by a scale factor. So you get P prime Q prime equals PQ times scale factor. So the fundamental theorem of similarity proves the original segment will always be parallel to the dilated segment. And the reason why they would be parallel is because they use the same scale factor. Okay? All right, so going back to our goal for today, we will learn how to prove the fundamental theorem of similarity using parallel lines and transversals and scale factors. What is the fundamental theorem of similarity? It is when you have a center point with 2 additional points and a scale factor, you can make parallel line segments. Okay? And that's what the fundamental theorem of similarity is. I have some practice problems that you're going to see in your packet when you get to school tomorrow. That's all I have. Okay, talk to you later.